Number 33. Lauren keeps track of the distances she travels in a taxi and what she pays. So they give us a table, and you can see that they're defining variables for us, D and F. The fare is what you have to pay, what she has to pay. If Lauren graphed the ordered pairs from the table, they will make a line, exponential shape, parabola, or none of these. So this is basically asking us about whether this is a linear function, exponential function, or a quadratic function. And it's a little tricky to tell because I want you to notice that D is not going at a constant interval here. This is +2, but this is +6. So one way to think about this is just to look at what those differences is, like what's the average growth rate. So for instance, if I do from here to here, this is I'm going to do it like this: 1275 minus 825. That's the change in y over 5 minus 3. It's equal to 1275 minus 825 is 4.5 over 2, which is equal to 225. Okay. If I did the same thing for this interval here, 2625 minus 1275 over 11 minus 5, I would get 26.25 minus 12.75, 13.5 or $13.50 over 6. And when I do this division, it turns out to be the same, 225. The units on this are dollars, right? And the units on this are miles, so this is dollars per mile. So even though it looked like something weird was happening, it turns out that these are the same rates. Another way that you could deal with this is by filling in the gaps here. So we had 3, 5, and then it jumped to 11. So let's fill this in with equal intervals: 7, 9, 11, 825, 1275, and 2625. Now, we didn't know what these middle ones were. There's a couple ways we could probably figure it out, but actually now that we know that this is 225, first thing I would just try is adding 225 to each one. So this would be $15. This would be 17.25. Did I skip something? Hang on a minute. Hi everyone. Well, I'd made a little error there, and then I started recording. I thought I was recording, but I wasn't, so I did a bunch of work, and the camera wasn't on. Anyway, welcome back. I noticed what was happening. I was going by $2.25 for every mile, but really this is going by 2 miles, so I needed to go by 450. So I corrected some values here, and it all worked out to get me the correct fare for 11 miles. I also worked backwards to find that at 0 miles it costs $1.50. Just by working backwards, but here I had to recognize that from 1 to 0 I was going only -1 miles, so instead of going back $4.50 I had to go back $2.25, and that allowed me to find this equation. The fare is equal to 450 over 2 times D plus the 150 that there was to start, and I wrote that in the box. I initially used X and Y, but realized that I needed to write it in terms of F and D, and since I'm writing in pen for the camera, I wasn't able to erase it, so I scratched it out. But of course, on the exam, you'll have a pencil. You should definitely erase that. And then it asks for the explanation of what these numbers in the equation are. Well, one more thing before I go on to that. One thing that I did was I used this equation to just check before I moved on. So I typed this equation into my graphing calculator, 2.25x plus 1.5, and I looked at the table. Oops, there's the graph. I looked at the table to confirm that at 11 miles it was $26.25, at 5 miles $12.75, at 3 miles $8.25, just to confirm I got these values in this table before I moved on. All right, and then in terms of what these numbers mean, the 225 is the amount that Lauren's getting charged per mile. Every time the taxi drives a mile, it charges her $2.25. So it is the charge for each mile that the taxi drives her. The 150, that's the starting amount, right, the base. It's the 150 that Lauren gets charged before the taxi goes anywhere. Essentially, when she gets in the cab, just to get picked up, it costs her $1.50, and then it's $2.25 per mile.